Alright, so today I'm going to show you how to do a simple docking procedure on orbit. Now I see a lot of questionable practices when people try to do this. It's pretty clear that nobody has any real idea of what the correct procedure is, and the fact of the matter is that docking in KSP is incredibly simple if you know what you're doing. So I'm going to show you how to do it. I'm also going to show you how to do a gravity turn. How to do a gravity turn in orbit to launch, and this is much more efficient than diddling around with the attitude control keys on your way to orbit and wasting half your fuel on drag losses. So let's just load this. I'm fairly certain this is the wrong thing, but it doesn't matter. Fuck it, we'll just use two of them. Why not, right? Alright, Valentina can fly this one. I'll show you how to do this launch, and I'll chop out the bit where I launch the other one, because it's not going to be terribly interesting. Yeah, physics extender. Alright, so in order to do a gravity turn, what you want to do is launch launch to a fairly limited height, pitch over a few degrees, and then use SAS to lock the prograde all the way to orbit. And as your prograde vector follows the curve of your trajectory, your spacecraft will pitch over to follow it, keeping you at the bare minimum of drag and hopefully pushing you to orbit. So I'm going to show you how to do this. So you simply launch like this, and once I get to, in this case, I'm going to say around 60 meters per second, I'm going to pitch over. It's called a pitch kick maneuver. Pitch over to around 5 degrees. Nothing crazy. And then once the prograde reticle has aligned with that, I'm just going to lock the prograde. Dead simple. I'm going to throttle down real quick because I want to have a slightly steeper ascent than this. That looks good. I think we're just going to it's a dead simple launch from there. All I have to do is hit stage every so often. Hopefully. We're at 5 kilometers now, climbing very quickly. Nice and simple. And as you can see, there are almost no drag forces. I'm just heading straight along my prograde curve, straight to orbit. And stage. And we're still accelerating. Everything's going smoothly. Apogee is 30 kilometers. Excellent. Just what I was hoping. Once the atmosphere gets to black, I'm going to stage off the fairing to lose some mass. Should be an very easy procedure. There's 800 meters per second coming up now, and our apogee is 50 kilometers. As you can see, we're on what's heading towards a nice flat profile on our way to orbit. I do apologize for the audio, which I imagine will be crap. Unfortunately, the only way I have of recording myself is to plug headphones into my phone and use those. It's not terribly good as things go. So let's just stage the fairing off in a few seconds here. As you can see, we're already at only 30 degrees pitch at 50 kilometers, which is it's perfect, really. We're going to be heading for around 100 meter or 100 kilometer orbit, hopefully. Maybe 150, I don't know. That looks good to me. Stage that off. And as you can see, we've made ourselves almost all the way out of the atmosphere, and we've used very little fuel, very little drag. It's going to be a simple matter to circularize here, and I'll just prepare my maneuver for that. It's nice and circular, isn't it? 81 by 110. So let's just adjust this slightly. Radial in to push that down. 102 by 90. 91 by 100. 100 by 100. 104 by 100. We'll just push that in ever so slightly, and now we have 100 by 100. As we're 85 kilometers, we can go ahead and begin to adjust our heading to our target. Now, you might have noticed something already. I need a lot more fuel than I have in this stage, so I'm going to go ahead and start the burn now. And that's going to last me just a few seconds here. Notice the time. 35 seconds until the burn should even start, and I'm already well into it. Well, that's because this stage, the circularization stage, doesn't have enough fuel to handle this, so we'll just go ahead and do our short little burn here. And while we're doing our circularization burn, I'd like to talk a little bit about what the point of a gravity turn is. See, I didn't have to make any adjustments to my heading, my pitch, or my yaw during the flight to orbit. All I ever had to do was hit stage, and it put me in a very, very short period of time into a nice flat orbit. And if you do this with any size of rocket, assuming you don't have wobbly oscillations from the terrible part coupling mechanics in KSP, you'll end up with a nice, easy ascent out of the atmosphere and on your way to orbit. If you want to, you can use an even steeper ascent profile, kicking over earlier and at a lower initial velocity, and I don't tend to do that. I prefer to do a second burn on orbit because I think it uses less fuel than all that flying sideways through thick, soupy atmosphere. And there we are. There we are. That's circular. Let's just check our orbit. 99 by 102. Pretty good. I think that's... I don't know what the eccentricity is. I'm not going to do that math in my head. So let's just do something real quick. So this will be easier to identify when we go to rendezvous with it. Let's make this a... how do you do that? Let's make this... rename vessel. We're going to call it a probe. Why not? We'll say this is Valentina. Okay, now we're just going to go back to the space hub. And of course, Valentina needs a friend. Everybody needs a friend. So we're going to go and we're going to get another one of these. Get out of here, Daftbert. Actually, get back in there, Daftbert. Leave you with pilots. I mean, it doesn't make a difference, but whatever. And we're going to launch this vessel. Now, the tricky part is eyeballing where you're going to need the spacecraft to be for your launch window. But I just did that. And as I can see, it's around here. Now, I know I spent about this much time putzing around and talking. So I need this spacecraft to be the same distance ahead that it took me to get to orbit to begin with. So we're going to say we're going to launch when it's around here. Let's set that as our target. We're going to launch when it's around here. So let's just scooch back a little bit. Oh, I might have overshot it. Yeah, I probably did. Doesn't matter though. In fact, I'd like to do this just before dawn so that I have all day to show you how the docking procedures work in KSP. So we're just going to scooch to here. One more go around for you, Valentina. And it's going to be right at daybreak. Excellent. That looks good to me. So let's have this all set up. We're going to do our pitch kick just like before at 60 meters per second and 5 degrees. 5, 6, 7, 8, and there we are. Hold that attitude until we have prograde alignment, and we'll just set this up. Now, this rocket isn't very good. I designed it in about 3 minutes just to get a workable sort of thing. I don't usually use spacecraft this size. Usually they are gigantic, hulking, 600-part behemoths. And as you can see, my heading isn't quite right. In fact, I need to be on exactly the other side of this to make it to Valentina. So I'm just going to push down a little bit. Just push down until we start to see that vector move to this side. I'm going to lock to prograde. Hopefully, I'll be able to burn up stage 1 fairly soon. But I can already tell there's going to be a problem. I did this wrong. Valentina is going to be way past me. What am I going to do? Well, it's very simple, actually. I'm going to, oddly enough, throttle down. And the reason I'm going to do that is because I want to move until I'm around here now. See, normally I'd be burning like hell at 50 degrees elevation, but now I'm going to be wanting to burn like hell at 40 degrees elevation. See, I want to circularize at a lower altitude than what I was originally targeting. So, once I get to around 40, 35 degrees elevation, I'm going to kick that motor back on. Of course, I'm using a bit more fuel on gravity loss, but I don't think it's a huge problem in this context. So let's throttle back up. And this should put us in a slightly lower orbit than we left Valentina in just a moment ago. And I'm going to go ahead and stage that now, just to save myself a little bit of fuel. And once I hit my apogee of around 80 kilometers, yeah, I'm going to say around 80 kilometers, then I'm going to cut throttle. As you can see, we're tilting over very rapidly. Our heading is almost aligned with Valentina's just because of that little kick we gave ourselves maybe, except it won't actually be. But our apogee is going to end up around the ascending node anyway, so I can just do my plane correction then and already be on target. Except I won't. I won't do it then. I'm going to cheat a little bit just to show you a clever little trick. Alright, that is stage 1 all burned up. We're just going to do our little plane adjustment here. But of course, if we do that, if we program in our plane adjustment, it's no longer correct. The reason for that is actually fairly simple. If you change your prograde vector, you change your pitch vector as well. Whatever it's called, I don't give a damn. You all know what I'm talking about, right? Okay. So now we're just going to lock to our target at D stage. Let's just get a quick burn real quick, just to get a pulse on how long it's going to take. And it says it's going to take 1 minute and 22 seconds. So that means we need to start our burn at T-minus 41 seconds. Right. So there we go. T-minus 44. 3, 2, stop. And that will ensure that our burn is evenly distributed between both the beginning and the before and the after of our maneuver node. Now, obviously, because the acceleration increases throughout the burn as we lose mass. It's not the most efficient way of doing this, and in fact, it's not the correct time to start the burn at all, but it's close enough. And the only correct way to calculate when you should actually start the burn as you're accelerating is to do calculus, and I don't feel like doing that just to play a silly little game. So, we're just going to eyeball it. And the 50-50 rule works very well. As you can see, we've got plenty of fuel in the tank for this simple task. 18, 9, 8, 7. Just keep your finger over the X key for this and count down in your head or out loud. 2, 1, 0. We're very close. Excellent. Perfect. Absolutely perfect. Now, let's consider what it will take to rendezvous with Valentina here. Well, our orbit is slightly below hers, so we're going to move faster. right? We move faster than Valentina, but it's not going to be terribly simple to calculate our maneuver. So we can just drag out this, and as you can see, we already have a near rendezvous. So if I click this, tell it to warp one maneuver further, hang on, there we are. If I actually go back just a little bit, we have a near perfect rendezvous. And I can adjust this rendezvous down to 0.0 kilometers in an incredibly simple way. First of all, if I move it this way and that, you can see the distance decreases. This is actually annoyingly precise that I've just eyeballed here, because it doesn't give me a great chance to demonstrate what I'm on about. But I'll show you anyway. Oh, didn't mean to do that. Now let's just delete this maneuver now, because I've already cocked it up. Add maneuver, prograde. Well, you know what? I'm just going to take this opportunity here to show you what I'm talking about how to calibrate your maneuvers. So we can see we have 41.3 kilometers of separation. Now I can get that down to 0, as we just saw, or 0.6 by simply moving this back and forth, but I'm not going to. So if I adjust prograde, as you can see it drops, and if I adjust retrograde, it increases. So what we want to do is adjust prograde out until we get to the smallest value that that can give us before it starts to increase again. Oh, see, it's just moved over there. It's still there though, so we'll click that. 2.1 kilometers, not too shabby. But as you can see, between there and there, 2.1, 2.2. That's the least that adjusting prograde can give us. So we're going to adjust it to that. Then we're going to push in radial. And as you can see, adjusting radial in, or yeah, that is radial in, moves our separation further. So if we just pull it out, we get to the minimum value that adjusting radially can give us. So that's 1.9 kilometers. And then if we adjust our normal and anti-normal nodes, we find that moving this way gives us even less separation, until we get down to around 1.3 kilometers. So we're going to move it back to 1.3. Then we're going to start all over again, because adjusting these other two vectors has adjusted this one. So we'll go like that. There we are, 0.4. 0.4 is the least distance we can get from adjusting prograde now. So if I adjust this again, I can get it down to still 0.4 kilometers is the least I can do. So if I adjust this to 0.3, I just saw it, there it is. So I'll adjust this again. Oops. A little bit too much. Well, you know what, 0.1 kilometers, that's good enough. So, we have an intercept at 0.1 kilometers. That's incredibly precise. And all we had to do was just procedurally adjust our target point, what's the word I'm looking for? Just procedurally adjust our maneuver. So we're going to warp to the next maneuver, execute this tiny 28.5 meter per second burn, and that will put us on our intercept to Valentina. And intercepting with Valentina is going to be even easier than that, as you'll see in a moment. Alright, now this says it's going to take 2 seconds to complete, but I'm not interested in a 2-second burn, because my precision here that I just got it was about 0.1 kilometers away. So if I adjust this down to a ridiculously low value, I can see that even at 1, I can get incredibly precise. So we're just going to warp to the movement here. And we're just going to do a very low throttle burn. Doesn't need to be much at all, because we want to get our intercept as precise as is humanly possible. Alrighty. Now let's take a look at what our intercept is. Target separation. Oh no, it's 1.1 kilometers. That's not what we wanted. So, we can still do the same thing we just did. We can actually cheat. We have reaction control thrusters already on the spacecraft. So, if we just roll ourselves to where we're level, because that's easier, let's agree on that, we can use the HN, IK, and JL keys to adjust in each of those 3 directions, just as we were doing with the maneuver node. So if I hit J, which thrusts the spacecraft to the left, it increases the separation. But if I hit L, and that thrusts it to the right, you can see it decreases until I hit 0.4 kilometers. So now I'm going to use prograde and retrograde. Well, actually it's not prograde and retrograde because I'm facing in some random direction, but it doesn't matter. Now I'm going to use H and N. H pushes it out, N, well, still we can't get below 0.4, so now I use I and K. I'm hitting I now, and now I'm down to 0.2, 0.1, 0.0. Excellent. Let's turn RCS off to avoid any sort of errors that could result from adjusting our attitude here. Then we're going to hit retrograde. Notice that I've set this to target. So it's the retrograde relative to retrograde direction as determined by our motion relative to our target. So this is our closest intercept here. We're going to warp here. Look at all the fuel we have left. Impressive. Now that's in 1 minute and 14 seconds, but we need to burn off 60 meters a second. So because we set ourselves to target retrograde, we're not actually pointing anywhere relative to the target. Actually, we are pointing directly at the target, but that's sort of coincidence in this context. We're now directly away from the target? I don't care. Once we hit this point here, which is coming up in 50 seconds, I'm going to burn retrograde relative to our target. And that means that I'm scrubbing off all the relative motion I have from the target, and that will align our orbits perfectly, and it effectively park us next to each other. I don't know what that is. Is that minimum? I have distant object enhancement active, and I think it's doing that. So let's just take a look at this. So we have 24, 23, 22, 21. I'm going to start it at 15, 15, 17, 16, 15. Okay, that is our rendezvous completed. Now let's check out our distance. She's only 0.6 kilometers away. Very good. Especially considering I sort of eyeballed that maneuver there. Now I'm going to rotate myself pro target. Can we see her? Yeah, I can't see her. She's gotta be in there somewhere though. So, I'm going to turn on RCS, and I'm going to hit H. There we go. And then I can just use these maneuvering jets, I, J, K, and L, to adjust until I see this prograde reticle directly aligned with our pro-target reticle, and then I can simply accelerate. And that will put me on a collision course with Valentina over there. Now why is that? Why do I want to use this maneuvering jet? Well, there's no eyeballing it. There's no eyeballing at all. Obviously, we'll have some air drift, and you can see she's right there now. We'll have some air drift as we move, but it's not too much. And it'll put us directly on an alignment course to Valentina. I don't have to do maneuvering nodes. I don't have to do anything other than just keep this prograde reticle, the yellow one, aligned with the pink target reticle. Let's go ahead and warp forwards just a little bit. And as you can see, the prograde reticle starts to move out of alignment of the target reticle. And the reason for that is the nuances of orbital mechanics. Now, I forget, unfortunately, which mission it was, but it was one of the Gemini missions where we performed the first orbital docking with an Agena target module. We discovered that it was impossible to actually rendezvous. They were trying to thrust directly at the target, as we're doing now, and they kept missing. Well, Buzz Aldrin literally ended up writing a book on orbital rendezvous as a result of this. He was the one who figured out exactly what was going on and how to rendezvous. So now I want to end up at parking orbit. Or park next to it, right? So I'm just going to push this until retrograde is locked right up onto here. And of course now all the controls are reversed. I'm just going to pop this until I want to keep this lined up on here as I move away. It's just more convenient. That way I don't have any other direction. Speed to scroll. There we are. We're parked. Good enough. Now, there's a trick to docking. You can. There are three main directions on orbit, right? You have prograde and retrograde. As you can see, prograde, retrograde. You also have radial in and radial out. However, this is not actually what I'm using. Radial in and radial out. However, those two directions move as you're on orbit, don't they? Because they have to follow the curvature of the orbit. Prograde continuously falls towards Kerbin, and radial out continuously changes direction as well. However, there is one direction that never changes. That is normal. And anti-normal, of course. So if you and another spacecraft are preparing to rendezvous, and you're in the same orbit, where the hell did Valentina just go? So she's right there. Where did you go? Over there. Huh? So if you're in orbit and you set your target to align itself to normal on orbit, you can then set yourself from your control node, which we'll set as the docking port. We can set ourselves to anti-normal. And now, these two will always be aligned. Of course, this isn't always easy. Sometimes it's very much easier said than done, and you don't want to do that. Such situations, very large spacecraft that are very unwieldy and slow, you don't want to do this. It's just a waste of time and effort, but it's very useful for getting the basics down. So we're going to turn on our thrusters. I guess I'm now Valentina. It doesn't matter though. Just going to back up to here. Then we're going to set. I'm just going to scrub off our speed here. We're going to set this docking port as our target. Okay. So with that docking port set as a target, you can see it shows up on here. Now, if I hit H until this prograde reticle comes around, I can align that prograde reticle directly with the target. Simply by using these keys on the right. And now, I'm on an intercept course with that docking port. Notice that these are blue. That's because I've hit caps lock to make them more precise. It's a very useful feature. Let's just move towards each other a little bit, and as you can see, there's a small amount of drift, but it's nothing too serious. I can still push it right back onto course, and if we zoom in now, what we can see happening is our docking ports are drifting slowly together, but I don't actually want them to hit like that. I'm going to back it off just a little bit, and we're docked. It's that simple. Now, I often hear people say things like, the squad needs to fix the docking ports, it doesn't work, it's all rubbish. And the fact of the matter is, they work really well. You just have to know your docking procedures, and they're dead simple once you do. But let's say we're not at normal and anti-normal. Let's say I'm just over here. Well, how do I dock then? Well, I'll just show you. Let's just back up a whole bunch. And I'm going to close my eyes. Oh, I've accidentally hit that button, haven't I? I'm just going to close my eyes and hit some buttons. J, K, L, until I'm no longer aligned with the target. So, let's just thrust forward to cancel our reverse momentum. And if I can still see him, I'm going to set my target. Now I'm aligned in some random direction, but it still doesn't matter, because I can still push my target reticle right to it. You can see quite a lot of velocity to scrub off there, but nothing too major. I've realigned myself manually with the target, and you'll notice one thing. I like to use small, gentle taps of the keyboard, just each time for great hand position. And look at that. We're already lined back up and right on position. It's the same procedure we just did just moments before. And I'm still keeping that targeting reticle aligned, backing off speed right before, and we're docked. It's that simple, it really is. So I hope you enjoyed this. You're welcome to subscribe or do whatever the fuck you want. I really don't care. This isn't my day job. I hope you had a nice day, and goodbye.